Hello everyone, welcome back to our channel. Today we are discussing about very short answer questions in motion in a straight line chapter. It is very important for board exams also. From this you are getting 1-2 marks question. And what is the importance of this chapter? This is the heart of the mechanics. From this only we know that what is distance, what is the displacement, what is velocity, what is acceleration, what are the equations of motion, everything we are getting the clarity from this topic only. Anyway, today our focus is on what are the very short answer questions from this. From this chapter, first question is why rest and motion are relative. So the answer is, first of all, what is the rest? The position does not change with respect to time. Here you look here, this board is there. This board position does not change until unless I am not moving. Suppose I don't want to disturb this board. This body is continuous to its state of rest. So its position does not change with respect to time. Suppose your vehicle is there. Okay, vehicle is always moving. Why? For the moving purpose only we are taking one vehicle there. So always it is in motion means sometimes with respect to time that is changing, that's why it is in motion. But our question is why rest and motion are relative to each other. Suppose two friends are there in bus. This is A and this is B. Your friend is here, one tree is there, and here friend is C. Now the bus is in moving condition. A and B both they were occupying their places. What you are saying with respect to C, both are in motion because the bus is in moving condition. But when you are looking at B and when you are looking at A, with respect to A, B is at rest. With respect to B, A is at rest. So same thing we are saying with respect to C, both are in motion. But with respect to A and B, both are at rest condition. That's why what we are saying, rest and motion are relative to each other. Not only this one. You know that on the earth, I am here. Now earth is always revolving around the sun and revolving around itself. It is in moving condition. But when I am standing like this here, time is passing. But I am at rest. But earth is moving, no? So what do you say? Rest and motion are relative to each other. If anybody is raising the question, what is your position? Is it rest or is it motion? Means you can say with respect to what? With respect to reference frame only, we can give the what is rest and what is the motion. And we are using one important thing is rest and motion are relative to each other. And this is one of the example for that. Then our second very short answer question is, how is average velocity different from instantaneous velocity? Suppose we want to travel 300 kilometers. We are using our car. That speedometer is showing sometimes it is 60 kmph. When the traffic is say 20 kmph. When that signal is there 0 kmph. Like that, in that speedometer is showing the different readings. Then finally we have started here. After 5 hours we are reached to the 300 kilometers. Then what is the average velocity? Total displacement 300. How much time we have taken? 300 by 5. So average velocity is how much? 60 kmph. 60 kmph. So average velocity, what is that? Total displacement by total time. So in our journey, even it is 20 sometime, if it is 80, if it is 100, if it is 0, we have calculated the total displacement by time. But what is the instantaneous velocity while driving? Suppose you got one call. Your mother, especially your mother is asking, what is the velocity? Means simply you are looking in speedometer and you say just 40 kmph like that. So at particular time, at particular instant, what is your velocity? What is your vehicle velocity? 40 kmph. So velocity at particular instant of time is called what? Instantaneous velocity. Total displacement by total time is called what? Average velocity. And one more question is there in this. when both are equal. In uniform motion, both are equal. Uniform motion means it covers equal distances in equal intervals of time. At that time, average instant, both are same. Then our third VSAQ is when the velocity is 0 but acceleration is not equals to 0, give one example. Generally, what do you say? Velocity is the rate of change of displacement, but then acceleration is the rate of change of velocity. But in our question, what they have given that when the acceleration is 0, but when the velocity is 0 but acceleration is not equals to 0. Look, when the body is projecting upwards, means it is moving away from the earth. So earth is always pulling that body. So velocity is reducing at one position. Velocity is 0, but still acceleration is not equals to 0. That is acceleration due to gravity. It is acting downwards. So how to write this one? When the body is projected upwards at particular, after traveling some distance, velocity is 0. Still that acceleration is not equals to 0. It is acting towards the center of the earth or vertically downwards, we should mention. Then our fourth VSAQ is find the average velocity if the body covers half of the distance is with V1 speed, remaining half of the distance with V2 speed. You are started at Hyderabad and you reach to the Karimnagar. Your total half of the distance, you are maintaining how much speed? V1, and remaining half is maintaining with V2, but we want average speed. So we are going through the average speed. Just now I said the total displacement is L by 2 plus L by 2. The problem is here we don't know about the time. So here T1 equals to distance by speed, L by 2V1, and T2 is how much? Same, distance by velocity or speed by V2. It should be right L by 2V2. Instead of T1 we are writing L by 2V1 plus L by 2V2. Then V average equals to, here L by 2 is the common within brackets 1 plus 1. Here also L by 2 is the common within brackets 1 by V1 plus 1 by V2. After simplification, V average equals to 2 by, but here we can take the LCM V1, V2. Here V2 plus V1. You know that A plus B equals to B plus A. V average equals to, it will reverse. You are getting 2V1, V2 by V1 plus V2. So what is the base of this question? We must remember that average velocity equals to total displacement by time. We don't know about the time, means we can find out distance by speed. Here also distance by speed. Then our fifth question is, one lift is there, it is coming downwards. Above the origin we can take the positive. Here we have to, they are giving some few conditions. What about the displacement, what about the velocity, and what about the acceleration when the lift is coming downwards. Look here, anyway the lift is coming downwards, the displacement we can take it x. It is reducing means total displacement is reducing, so this is less than 0. Then whenever displacement is less than 0, velocity is also less than 0, but it is coming towards the earth, means acceleration is increases, that is A is greater than 0. A is greater than 0. Then our sixth question is, a uniformly moving cricket ball is hit by the bat. Draw the graph between acceleration and time. I think you like this game very well, especially boys. See, we are playing, in that also we should observe the physics. When the ball is hit by the bat, what happens? Don't say to me this is going to 4, 6, like he made 2 runs at that one. Here our focus is on, we are drawing the graph between acceleration and time. Time we are taking on x-axis, acceleration we are taking on y-axis. When the ball, just you should imagine when the ball is coming, this is the bat we feel. Otherwise, you If you want to see really, this is the bat. This is the bat. When the ball is coming towards this, what happens? Here it strikes this one. Immediately it is changing the direction. So in this graph we can show that. Simply we should draw this graph. This is the acceleration time graph. Our seventh question is give the example of one-dimensional motion where a particle moving along the positive x direction comes to rest periodically. What is the periodic motion? If the body is repeating its motion in equal intervals of time. Earth is also one of the example. It is revolving around itself. It takes how much time? 24 hours. But here we should give an example. What is that? That example is the simple harmonic motion. The condition is, suppose we are taking one pendulum. It is coming in oscillation chapter also. When it is pulled one side in that wall clocks also, we should observe that one. That pendulum is oscillating like this. This is called the periodic motion. Why? It is repeating its motion in equal intervals of time. So at what position? Here the question is it's periodically and moves forward, and here moving along the positive x direction. Here it comes to rest periodically. The question is give an example. It comes to rest periodically means you can say that example is the simple harmonic motion. And explanation, look here. This is the mean position. This is the extreme position 1. This is the extreme position 2. When it is pulled one side and leave it, it is making going forward direction and coming backward direction. Here the velocity is 0. That's why once again it is going backward. Once again here velocity is 0. That's why it is coming like this. So it is repeating its motion and particular position, that's velocity is 0. That example is simple harmonic motion. Then our eighth very short answer question in this chapter is, they have given one expression, A equals to G minus BV. Here G is the acceleration due to gravity, B is the constant and V is the velocity. In this question clearly they mention that velocity is constant, means velocity is not changing with respect to time. Then what about acceleration? Whenever velocity is changing, that is called as a acceleration. Here velocity is constant means acceleration equals to 0. So A equals to 0. Substitute in this, 0 equals to G minus BV. After simplification, BV equals to G. Then velocity is G by V. So here we should remember that whenever velocity is constant, acceleration is 0. Acceleration is 0. That's why instead of A we are writing 0. Then our ninth question is, our ninth very short answer question is, see, we are in train. One object, I want to throw this marker through the window of the train. What we feel? It is going straightly like that freely falling body. But the person who is outside the train, it is having which path? Parabolic path. Not only this one, during the floods, helicopters are there. They are dropping the food packets. One helicopter is there and they are dropping the food packets. So with respect to helicopter, this is having straight line path. But the person who is here, that is coming like this, they will catch. If they are under this one, they won't get this one. It is having the parabolic path. So same food packet with respect to the person in helicopter, it is like freely falling body, straight line path. And the person who is like observer on the ground, it is having which path? Parabolic path. So it is giving one of the example. You can otherwise, when you throw one object through the window, with respect to the person in train, that is the straight line. The person who is on ground or platform, it is having the parabolic path. Then our last very short answer question from this chapter is, they have taken one loaded spring. They have taken one loaded spring. They attached one block of mass is M. And the question is, when is the magnitude of acceleration is maximum? It is we are applying the force here, then it is making the vibrations here like this. When the acceleration is maximum, you know that in simple harmonic motion A equals to minus omega square y. So A is directly proportional to minus y. More displacement, more acceleration. It is possible at extreme position. Not only this one, this is also same condition. At extreme position, these are having the maximum acceleration because the displacement is maximum in that condition. Thank you everyone.